Good evening everyone. So how are you all? I hope everyone is good. Okay. So let us wait a few more seconds, then we will start. Till then, anyone have to say anything, any doubts from the previous class or any query? Good evening. Good evening, Dilshad. Good evening, Anpurna. Good evening, Lakshmi. Good evening, Monu. Okay. So people are still joining. So it's 6:31. So yes, I would be taking 1 hour class only today. So the 30-minute slot, which is after the 1 hour, I am keeping it as a buffer. Okay, so people were telling yesterday, sir, take only 1 hour class. Means after 1 hour, the flow breaks. So okay, so at some day when the topic is vast and we have to cover it, that day we will extend it to 1 hour 30 minutes. Apart from that, we will normally try to keep it within 1 hour. Okay, so good evening, everyone. Very good evening to all of you. Welcome to online study for you. So in the previous class, we have completed the topic linked list, all the different types of linked list. So see, Sunil, I have not studied data structure from one particular point. Okay, so the thing which I am delivering to you, those things are, I can say, assembled. Some things I have studied from paid course, some are from free resources, some are from the books. Okay, there is a good book. Its name is I'm forgetting its name, but it is for C programmers. Okay, I will tell you that name. So the concept in that book is very much good. So the concepts I have taken from there, but in that book the data structure has been implemented using the C programming. So the knowledge which I am delivering you is assembled. Okay, the best some knowledge the complexity which I taught you. So those things I have learned from the Unacademy. Okay, so the best thing I am providing. Okay, the best knowledge from different sources. Okay, so let me just quickly share the presentation. This was the presentation, and the topics which we have covered till now are these. That is basics we have covered, in which we have seen the introduction, recursion, as well as runtime analysis. Yesterday we have completed the physical data structure, that were array and linked list. Now, why these two are called as physical data structure? Can anyone tell me? You have all attended the introductory class, so there I have already said that. So can you tell me why these are known as physical data structure? Anyone? Quickly, quickly. Even if you are wrong, doesn't matter. Give it a try. Yes, correct. Who said this? So yes, Sanil said that with the help of this, we can implement logical data structure. So using physical data structures, we can implement these logical data structure. Now, this physical data structure, second point is also correct, given by Dirjal, that it does not require any DS for implementation. Okay. So these physical data structures are stand alone. Okay. So we can call them as stand alone. Now, whenever you create an array, it is already present in the RAM. You can just write the syntax for it, and it will be declared. The same thing is for linked list. You have to just create a set of objects. All right. So that is, these are standalone, and using this we can create logical data structures. Now today we are going to start stack. Okay, so today we are going to start stacks. Now stack can be implemented using two things. Either we can do using linked list, or we can do using array. Okay, all these data structure can be implemented using two things, but we are going to strictly follow linked list implementation. The reason which I am telling you that if you go with linked list representation, your life will be very easy. So why I am telling like that? Because the implementation is very easy to understand, and you can just I can say relate it to all the things which we have done in the linked list chapter. Now today when I am going to show you stack, you will see all the codings are similar. The concept which we are following is just similar. Okay, so shall we jump to stack? Are we good to go? Give a yes or no, everyone. Cool. So let me go to the slide where I have written stack. So distance, recursion. Okay. So I hope that you have seen the these things, that what were the practical uses of linked list I've discussed yesterday. Those who haven't seen, just read it or just see the recordings for yesterday. Okay, so these are some important questions. They will directly ask in interviews. If you know linked list, give me some practical example. So you can tell these. Now we are going to start stack data structure. Now what is a stack? So for that I am going to show you some diagrams. Let me hide this. Okay. So what is a stack? So can you see this figure? What you can see here? You can see a beautiful woman wearing a set of bangles. Okay, when we cannot see the woman. So she is wearing a set of bangles. Now, isn't something common in these two figures? What is the common thing? Okay, so I think you are not getting the hint. Now I am giving you one more figure. So this is one more figure. Now can you tell what is the common? So the common thing is the way we insert or remove a particular element. You can see when this woman was wearing this bangles, she inserted this bangle first, that is one. Then she inserted the second bangle. Then she inserted the third bangle and so on. Now, can she remove, after inserting all the bangles, can she directly remove the first bangle? No, it is not at all possible. Okay, only possibility is that she would be breaking all these bangles. So the insertion order, you can see here also the insertion order is similar. First we kept the first cup, then we kept the second cup inside that, then we kept the third cup and so on. Suppose if we want to extract or take out the third cup, okay, if you want to take out the third cup, what is the possibility? Only possibility is that until we pick up all these cups, okay, whatever it is, cup or bowl, until we pick up all these bowls from this position, means above the three, we cannot pick up the third bowl. Now same thing is with this also. Okay, what we call this? I don't know what we call this. Okay, this is a logo for VLC Media Player. Can it, if you anyone know what is it is called, tell me. Yes, Naveen, I was telling that only. So these you can see on the roads. Okay, for obstruction they keep this. So you can see if we keep it in this format. Okay, if we keep it as a stack, then also how we can take out from bottom, only if we remove the top one. So they are following a particular what we can say pattern in insertion and taking out. So stack is a linear data structure. So this is important. Stack is a linear data structure which follows a particular order in which the operations are performed. Now these operations have some names. So many have already given the answer. Okay, Nith Lakshmi has given the answer, that is LIFO and FILO. So that is correct. So the order may be LIFO, that is last in, first out, or FILO, that is first in, last out. So let me show you. Suppose this bangle has inserted at last. Now when it will come out? Sorry, this bangle has inserted at first. Okay, first we have inserted this bangle, but it will come out at last only. So this is known as first in, last out. Okay, so the things which we are inserting at first will come out last. In the same way, this is the first bangle. Now the first bangle was inserted at last, but when we will start removing the bangles, it will come out at first only. So that is what, last in, first out. So these two principles are followed by any stack. Now I think you all have already seen how stacks are normally represented while I was teaching recursion. Yes, sure. Amir, if it is not allowed, it is already mentioned. Okay. So see, in Java we have collection frameworks. Okay, in Java we have collection frameworks. You can directly use them in your examinations. Okay, it is a practical thing in the examination. Will you have time enough to implement the whole? I think it is 150 or 200 lines of code for a simple linked list. Is it possible? So no, it is not possible. For searching, sorting also operations, you have functions like arrays, dot sort. Okay, so these operations you can perform. Okay, you have functions for binary search. So that will help you to use that. You cannot write the complete algorithm in your examination in the coding contest. But yes, in some coding contests, predefined functions are not allowed, but that is mentioned there. But then most of the time, in exams like Capgemini, Wipro, TCS, Infosys, you can easily use the predefined collection frameworks, okay, the linked list. So that is present in the util package, and I have taught those things in the course, that is Core Java. You can check out there. So yes, so let us quickly see how a stack works. So some operations about creation of stack. So before, let us see how a stack works. So suppose this is a stack. If we want to insert element, what we can do? We can do push operation. We have an operation known as push. Let me bring the all operations here. So one is create stack. So when the stack will be created, so whenever we create the class object, so at that point stack will be created, same as linked list. Now push is the second function. Now in push, what does it does? If you want to insert the element into the stack, we use the push function. So it accepts one parameter. So what is the parameter it accepts? Suppose we are doing push 10. So it will push 10 inside this stack. Now we are doing push 20. So it will insert 20 inside the stack. You can see elements are inserted one after another. Now next operation is pop. Now pop, what it will do? It will return a value. Okay, its return type is integer. It will return the element present at the topmost position. Suppose we are storing it some variable, storing in some variable like int a, and we are doing pop. So this 20 will be removed from here. I know you all know these things. This 20 will be removed from here, and it will be stored in the variable a. So this a will be storing now 20. See, stack is called linear data structure because we are storing the data in a linear fashion as we used to do in a linked list. Now every node is pointing to one element only. So while you iterate, there is only one possibility that you can go in a linear fashion. You cannot have branches. So when we will study tree, we will study. So the linear word will be replaced. Just a second. The linear word will be replaced by a word known as hierarchical. Okay. So this means it's hierarchical. CHI. Okay, CHICA. So this means what? We are storing the data in the form of tree or network. So when we will study the hierarchical, then you can easily understand the difference between linear and hierarchical. Alright. Okay, so again I have erased all the things. So pop will bring us the topmost element. So suppose this is the linked list. This is the stack. We have elements 1, 2, 3, 4. Now we want to do pop. So if we are using suppose linked list concept, so we should have something which should be pointing at the topmost node. So earlier we used to have a head. In the same way, we are replacing the head with the top element. So we will create a reference that will be top. Now for after pop we have p. Now since the pop removes the element, topmost element, p just sees what is at the top. It doesn't remove that. Now when you will do pop, this one will be removed from here. But when you will do p, this one will be not removed, but it will just give you the output. Okay, suppose if you are storing int a is equal to p, so a will be storing 1, but this 1 won't be removed from here. Okay, it will be still there. But if you do pop, if you perform the operation pop, this 1 will be also removed and returned. Now we are going to discuss all these operations more deeply when we will do the coding part. I am just giving you a brief idea. Okay. So next we have check if it is empty. Now how we can implement this? Okay. Again I erase. So check if it is empty means what? We have to check if the stack is empty or not. So for that we have already created something known as top. Now if this top is pointing to null, can we say that the stack is empty? Yeah, cool. Mir, you are very much correct. So those who are not getting this, I will show you the coding and you will see it is exactly similar to the linked list. Why? Because we are using linked list only to implement that. Just understand the operations, which operations we are going to create. So for all these you can see operations, we are going to create one functions for each. Okay, not for create stack. When we will create the object, we will already created. Now then we have a delete stack. So we can delete a stack by dereferencing the object of the class. Now, okay, so before going to complexity, let us switch to the coding part. So I will try to end quickly today, and also I will not rush. Let's close this. Okay, so let me create a new whiteboard. Alright. So is this method good for you all? Means I am keeping both things in parallel. I think it is efficient because it will help you to, we can do the same thing, both things together. So before that, let me create a class and name it as, so I was creating packages also. So I am creating a new package only. Still we are going to have only one type of stack. Still let me keep it inside the package. So I am creating a new package and naming it as stack. Hope you all are not finding any difficulty from taking the codes from what is that? The GitHub. Okay, if you find any issue, just ping me. So inside this stack, I'm creating a new class. Let me name it as stack only. So this is done. The stack class is created. Okay, so its package is stack. Now let us create the class. Okay, so let us create a class for the node, and let me keep it here. So for one particular node, what I'm going to do, I'm going to keep a top. Suppose if the stack is empty, so what will happen? The top will be pointing to null in case of the stack is empty. And what will be the type, the data type for this top? It will be nothing but node. So what I'm going to do, every element, suppose if I insert element 10 in the stack, what it will have? It will be having two compartments. First is for the data 10, and second is for the previous element which is already present in the stack. Suppose if there is no element, it should be pointing to null, and top should be pointing to this element. If already elements are present, suppose then if you are entering 10, suppose if already 11 is present, so it should look like this. Okay, now so we are going to create a node type class. Okay, so let us do that. Yeah, exactly same thing, man. Instead of the head, we are using top. So so I am creating the class. Let it be node. And what things it should have? So I think now you all know that we are having a data and we are having next. So next will be of node type because it's the reference of the next node. So I'm naming it as next. Now I'm also creating a constructor. Now what is the use of this constructor? So when the object is created for creating a new node. So I'm writing here for creating new node. And inside this, let me have the constructor. It will accept what? It will accept the data when the object is created, and it will assign that data is equal to D and next is equal to null. So if you don't keep next as null, then also doesn't matter, but for understanding purpose, you should write like this only. Cool. So this is done. Okay, now what we need? We need a top. So I'm writing here top reference, and I'm creating it of which type? It would be of node type, and its name is top. Okay, making sense or not? Let me have the main block. So here I'm writing public static void main. Done. Okay, shall I copy all those things? So that will also save time. So I'm copying the main block. Okay, don't worry. Just I'm copying the things which we have in the main block. That is the switch case kind of thing. So this was the code done by me when I was, I think, in third year or at the end of third year. So I'm copying it. I think this is in the switch. This is in the white. And I am keeping it inside the okay, I will explain and then only I will move forward. So let me import the scanner class. So import java dot util dot let it star only. Now see, we have not created the operations, so that's why these are red in color. These functions we have to create. Now what I'm doing, I'm creating the object of scanner class. Then we are creating the object of the stack class, which we have just now created above. So when this object is created, our stack is created, and there is a top variable which is allocated with what? Which is allocated with null. So when we do this, that thing occurs. Now suppose if we create multiple objects for this stack class, what will happen? Multiple top variables will be created and pointing to null. It means in that way we can create multiple stacks. Okay. So now we are doing operations. Okay, we are keeping while as true, and we are repeating these set of operations. So one is for push, second is for pop, third is for peek, fourth is for check if the stack is empty or not. 5 is for printing the stack elements. See, we cannot access the elements in between, but I am keeping this function to for the sake of if when we do the what we can say input output check, so then we can see what is the elements in the stack. So then we are having 6 as deleting the stack and exit, and for all the cases we have wrote like this. So let us create functions one by one and see them. So the node is created successfully. After the creation of the node, I am creating the push operation. So let it be pushing element in the stack. Now this should be accepting one parameter, that is the data. So let it be public void and let its name be push. It is accepting one in type of data. Now one more thing which I wanted to tell, I've changed in all the codes which I have pushed. See, I want to keep this top as private. So why I'm keeping it as private? So it is necessary because when we have created a function, so there is no need of accessing the top outside the class. Okay, the top is required where? Only by the functions of that particular stack. You can see in double circular digits, the need for head and tail are where? Only in the functions definition only. From the main block, we don't need those operations. So that's why what I have done, okay, you can check, I've changed in the GitHub link. I created this as private. See, if the tail is not private, now I am going to show you the difference. From the main, if I have the li as the object of that class. Now from li, I should allow only access to only the functions, not the head and tail. But see, if I do li dot, you can see I can access tail as well as head. So for that reason, I am keeping those as private. Let us move to a stack. So that's why I have created it as private. Now for pushing, let us see diagrammatically first. So for pushing, what we need to do. See, for pushing, first step is we are going to create a node. So a new node will be created and it should be pointing to null and the data will be inserted. So let us write this first. So that is the same thing, that node, new node. Okay, you can take any name, but I am using new node because it is understandable. Node new node is equal to new node and the data that is getting me. This is done. So this is how we are creating a new node. Now we are having top as null. Suppose if the list stack is empty, we are having top as null. So what we want to do? We want to change this. Okay, suppose the stack is full only. First, let us take that situation. Suppose this top is having some elements. Now we have to strictly keep it as what? We have to strictly keep it as that we have to insert at this position. We cannot insert any other positions apart from this. Yes or no? We have to strictly keep it like that, so we can insert only at top. So what I'm going to do, I'm going to change new node dot next, that is nothing but this node, to the top. Yes or no? And later I am going to change top is equal to new node. So these two operations I am going to do after creation of the new node. So you can see this is the new node created, and the operations, let me write here that new node dot next is equal to top, and top should be changed to what? Top should be changed to the new node. So this is just enough for push operation. You can see this will also work when the stack is empty. Suppose the stack is empty. Okay, top is pointing to null, and we have a new node which is also pointing to null. So what we are doing? We are doing new node dot next is equal to top. So this will be again pointing to null only. That is the next of top. Okay, that is where top is pointing. Then top is changed to new node. So top is really pointing here. So you can see it is looking like what? It is looking like this. Top is pointing to the new node and new node is pointing to the null. Are you all here? Are you listening? Let me check how many of you are there. Okay, I can see 23 students. Cool. So is the pushing operation clear? This is the enough thing for pushing. Yes. So now let us check. Okay, we will check at last when we create all the operations. Now let me show you. One is for pushing. So it will say, when the case one will work, it will say it will tell that enter an element. That element will be accepted using sc.nested and it is passed in the push function. So it will be successfully pushed in the stack. Now, do we need to create a situation when the stack will be filled? Tell me yes or no. Do we have to take care of that situation? Yes or no? Yes. Answer carefully. I can see one correct answer, that is given by Jasmeet. And Anpurna has also given the correct answer. So already, yes, here you are absolutely right. The reason is because we are using linked list. So normally when we study stack, so we study two situations. First situation is underflow. Underflow means what? If the stack is already empty and we are trying to extract elements, mean pop elements. So at that situation, we have underflow situation. So this is correct. We will also face this situation in linked list because at some point our stack will be empty, but we will never face a overflow situation. We will never face an overflow situation when we are using a linked list. Why? Because there is a no limit of insertion of nodes. We can create multiple nodes. Alright. So our stack will never be filled. But yes, if the same thing we were doing using the array, so for array implementation, if we have to, while the creation of the stack only, at that point you have to mention the size of the stack. And at some point the stack will be get completely filled. So you have to show that overflow situation. But here this is the benefit when we are using the linked list. So there is no need of creating the overflow situation. Okay, what is overflow situation? When the stack is filled and then we are trying to push element. So this is overflow situation which will never occur in a stack. So we are done with the push operation. What next we can do? We can create the pop operation. So I am writing here that popping elements from stack. So for this, now tell me, do I need to return an element or I should keep it void? So first thing we know, okay, I'm keeping a dash here. So what should be the return type? I'm naming it as pop, and we know that we don't have to accept any parameter. Why? Because we are taking out elements. Let me check the comments. Int, cool. So why we are keeping this as int? Because we are popping out elements, so we have to return that value also. So that's why we are keeping the return type as int. So now we are implementing this pop function. So before implementing pop function, let me implement one function that is empty. Okay, how we can check if the stack is empty? So we used to in the linked list we used to check what if the head is equal to null, then we used to do return. So what we can do here, we can also check here that if the top is equal to null, we can return. But I'm not doing this because we already have a function for checking if it is empty or not. So I'm doing if is empty. I will create this function, don't worry, and this is empty will do that same thing only. So let us declare the if is empty function first. So I am creating the is empty function. Let me write it as that if check if the stack is empty or not. Let me see the comments. Yes, you all are correct, guys. That top should be equal to null. But for that, I am having one more function only. So I will use that function in other functions whenever I need to check the stack is empty or not. So I am keeping it as public. Return type should be boolean because it should return true, either true or false. Its name is empty. There is no need of any parameter. And what it can return. So if this top is equal to null, I can just return. You can see the same thing you can also implement in the linked list also. Okay, if the linked list is empty or not, what you can do? I have not created at that point because there it was not necessary at that position. But at this position you have to learn this. In stack it is used. So if this, okay, we have to return true. Otherwise it means what it is not empty. So I'm returning as false. So this function I hope that there is no confusion. I don't have to show diagrammatically. So I am using this function only in the pop. Now I am checking if it is empty. What I can do? Can we pop elements? So no, we cannot pop elements. So we can simply display a message system.out.println, and we can print that the stack is empty. Or can we just say underflow? So that will be more technically right. Okay, underflow situation. Which part, Diksha, you are not getting? Just tell me. See what I have done. So how can we check if the stack is empty or not? So see, we have a top. If we have elements in the stack will look like this. nothing but similar like a linked list. If we remove all the elements, how the stack will be looking like? The top will be pointing to null. Okay, this is our theory. Okay, we have not coded that, so we will code that just now. Okay, when we will do all the pop operations, at last the top will be pointing to null. So this is the condition which tells us that the stack is empty. Now for this I have created a function only. Okay, is empty. This function will return boolean type of value, means either true or false. So in when I was creating pop, I have to check first if there is element present in the stack or not. So what I used to do earlier, I used to check head is equal to null. In the same way we can do top is equal to null. But since we have created a function, can't we use that function only? So that's why I'm using here if is empty. Means if the stack is empty, what we have to do? We have to show a message that under flow situation. Now still we have to return some value. Since the return type is int, so I'm assuming that if there is no element in the stack will return -1. Okay, so this is a normal assumption which is done everywhere. Alright, so this is done. Otherwise what we can do? Just tell me. There is two situations. Okay, there is only one situation, that element is present in the stack. Suppose top is here, this top is pointing to 1, this is pointing to 2, this is pointing to 3. Okay, let me show you how this is actually a linked list. So this is nothing like a stack only. Okay, so first we have inserted 3 only, then it has come at last. So this is 3 inside, then we have 2, then we have 1, and this 1 is pointed by top. So we can do what? If you want to remove elements, we can only remove elements from the beginning only. Okay, so that we should strictly follow the operation or the logic for stack. So we can say top dot next. Sorry, we can say that. Okay, first we have to extract this. So I am keeping a variable result. Okay, which should be of int type. So I am keeping result as top dot data. Why I am keeping it as this? So it will store what? It will store 1, because later I can return this value. Now I am dereferencing the top to what? I am dereferencing to top dot next. So top is updated to top dot next. You can see how easily we have eliminated this element. Now this is what happened. It has been popped. Now lastly we can return result. Yes or no? Making sense? These situations for pop. Tell me. Mihir, what? Why are you wrong? You are right, Mihir. Top will be equal to top dot next. Cool. Okay, if you have any doubt, just tell me. Okay, I will again explain this. So see, this will also work when we have only single element. Suppose our top is pointing to only one node and the next is pointing to null. It means what? We are having only one element in the stack. So this data will be fetched in the result variable. Then we are doing top is equal to top dot next. So this is pointing to null and we are returning the result. So now the stack will be empty, means top is pointing to null. It is working fine in both the situations. So let me write it here after this if block. So when we are at line number 37, okay, when the compiler reaches line number 37, it means what? It means the stack is not empty. So we can do, I'm creating result. So in result is equal to, see, we cannot do result after we are dereferencing top, because then the reference to the first node is lost. Making sense or not? Means the storing of data should be done at first only. Making sense? Anyone have any doubt? The fetching of data from this node should be done at first. Why? Because later we have no reference. You can see no reference is going to this node. Cool. So that's why we are doing int result is equal to top dot data. Okay, this is done. Why it was not showing data? Let me at top, because it is showing top dot data. Then we are changing top to what? Top is equal to top dot next. Lastly, we are returning the result. Just take a look at it. Take a quick look. If any doubt, tell me. Okay, now I think you don't have any doubt. Okay, we have just seen everything. So what more operations are left? We have done pushing, we have done popping. So popping, let us see what we are doing in the main block. So this case 2 is for popping. and we are not printing any message. The sooner we press 2, what it will show? It will show this element pop. Otherwise, if it is empty, it will show -1 pop, and it will also show a message that stack is empty. Okay, not stack is empty, underflow situation, which will be printed because of this if block. Now let us create a function for peak. So can anyone tell me quickly that what was peak? Just remind us what is peak, anyone? It is also returning a value, we all know. Returning top dot data, yes, correct. So yes, everyone is correct. So we are not taking out the data, we are just peeking. Peeking means what? Seeing, quickly seeing that what is present at the top. We are not eliminating that. Okay. So for that we can, the basic thing is what? The basic thing is we have to return top dot data. So in one line we can say we have to return top dot data. But one thing we have to make sure, suppose if this top is pointing to null, it will show a null pointer exception. So for that, first we have to, every time we have to check the stack is empty or not. So we can do that by checking if the top is equal to null or not, or we also have a predefined function that is empty. Now if it is empty, we can show this thing. Okay, that underflow situation, the stack is empty. So this is not an underflow situation. Let me write here stack is empty. Underflow means what? When you are trying to extract elements and the stack is empty. Okay, we are not extracting elements here, so I am writing that stack is empty. I hope it is making sense to everyone. Okay, and the return type is int here. So picking is also done, I think. Yes, it is done. Now next we have, what is left? So we have done for checking if the stack is empty. You can see this is the function to check the stack is empty or not. Last, we can create a function for printing the stack elements. So printing the elements of the stack. Okay, tell me what is the logic, everyone? I want you to speak. So this should not be returning anything, neither it should be accepting any parameter. Okay, how we are going to iterate through a stack? Yes, correct. So Mihir, you are absolutely correct. So we have already done this thing 4 times. Okay, in the 4 types of linked lists. So we are going to iterate using while temp not equal to null. We can take it in a temp. Okay, we cannot iterate using top. Otherwise the top reference will be changed. We have to copy the top in a temp variable, then we can iterate. So before iterating, if the stack is empty, so we can do the same thing, that we can print, where is that? So we can say that the stack is empty and we can return minus. Okay, so there is no need to return because it is a void type. So we can print stack is empty. Yes or no? And we can return also, means it should end here. Otherwise, in all the other situations, we can create a temporary memory temporary object reference, which is initially pointing to the top, which is nothing but our head only in terms of linked list. Now, while this, let me see what you all are commenting. To see the elements without deleting, okay, that is peak. Return result while top not equal to null. Yes, so you are very much trained. So okay, let us do this. While temp is not equal to null. Now what should be written inside this while loop? We have to print the element, so we should write system.out.print. Let it be print ln only. Okay, so you can see it more like a stack, one below other. So I am writing temp dot data. Okay, so these are simple things that we are accessing every node one by one and we are printing the data. And after every printing, we have to change temp is equal to. But what? But we can print data without temp variable, I think. Try Mihir. See. Okay, Mihir question is very much correct. Okay, he has given a very nice question. Can anyone answer me? Is he right or not? Everyone see the comment given by me. He is telling that what is the need of creating the reference copy of top? Can't we just do using top, and we can do top is equal to top dot next? Tell me, will it work? Agree? Cool. What about others? We will lose reference. Yes, Divjal has given the absolutely correct answer. So this can be your question in interviews also. Let me see what others are telling. So yes, we can print, but reference will be lost. Cool. Top will be changed. Yes. See, we cannot disturb this top. Okay, uh, if we have this top and these are some elements, these are some nodes. When you will iterate, this top will be shifted from here, and lastly after one iteration, it will be pointing till this. So first time you can easily print the list, but if you try to print the list second time, it will show what the stack is empty. But is it empty? No, you have disturbed the top. You should have top fixed here. You cannot disturb this top from here. That's why in every time you have seen in linked list, I was creating a reference. Who have asked this question? Is it clear? It is a very good question. Okay. All right. So that's why we are using temporary object reference. So temp is equal to temp dot next. So this is done, and this is how we can iterate through the stack. Now I think all the operations are done. So we have done for push, we have done for pop, we have done for peek, we have done for check empty, printing the stack. Cool. Here. So okay, let us check this. I hope it should work right. Okay, if some error is there, you can tell me what is the error. Then I will make it correct. So one is for inserting elements at front. See, only you can also add functions, but when you are creating a stack, you should strictly make it that insertion at front only. Okay, you cannot insert at bottom. So I am entering 10. I am entering. Let me run it again at plus 2. Okay, tell me what will be at top if I am entering 10 and I am entering 20 and if I am entering 30. What will be at top? Now, what is at top? Yes, Priyam, we can also create a function to check the size. Yes, everyone is correct. 30 is at top. See, we can also, okay, let me check this, then I will talk about the size. So, inserting at front. Okay, I've run the function for double circular interest. Sorry, my bad. So it was the previously run function, so it ran. So let me run it from here. Okay, so I have done 1, then I've inserted 10, then I've pressed 1, then I've inserted 20, then I've pressed 1, then I've inserted 30. And you all said that 30 should be at the top. So how I can check that? I can do peek. So you can see 3 is for peeking the top. So yes, top is equal to 30, correct? Now let us see after printing how it looks like. So if I press 5, you can see 30, 20, 10. So 30 is at the top. If I want to remove elements, so first I have to remove 30. Then only I can take out this 20. Okay, and after that only I can take out this 10. You can see when I will do pop. So I am pressing 2. So it is telling that 30 is pop. And again if I press 5, you can see 20 and 10 are still in the stack. Now if I press 4, it will check if the stack is empty or not. You can see it is telling that stack is not empty. Now if I keep doing popping, so if I am pressing 2, 20 is pop. If I press 2, 10 is pop. Now what will happen if I again pop? So if I again pop, it will show underflow situation. So we can't insert at the end. No, we cannot. See, Sunil can create a function to insert at the end, but that doesn't make a point, okay, because we are creating a stack data structure. You can check collection frameworks. In the collection frameworks, go to the, okay, import a package java.tuple.star and use the stack class. So when you will use that stack class, let me show you here only. We have imported the util package. Okay, that won't be a part of our code. So we have imported util. In the util, we have the stack, the collection framework stack. So let me write somewhere. Okay, let me write in the main block. So it will be also similar to stack only. Okay, so I'm writing stack. See, this stack is from the class and this stack is from the util package. So I'm using this stack. Okay, so I'm creating an object of the java.util.stack. Let it be s is equal to new stack. So this is not our stack which we have created. Now, if I okay, let it be s1 because we have already used s. I'm just showing you. If I press s dot, see we have operations is empty, we have peek, we have pop, we have print stack, we have push, but there is no function that insertion at end. So you should follow the rules which a stack follows. Otherwise, there is no point. It will all, or it will be a simple linked list only. So okay, so I hope you understood this. Let me run this again. So we have inserted 10, then we have inserted 20, then we have inserted 30. Now if I do print, so it will show it 30, 20, 10. If I do pop, 30 is pop, 20 is pop, again 10 is pop. Now every time it will show underflow situation, you can see. Now 5 is for printing stack. If I print the stack, again it will show stack is empty. If I peek the stack, it will show stack is empty. And if I press 6, it will stop. Yes, now the question comes that, okay, so in some stack operations, you will see there is a function which says the length of stack. So there are many ways you can implement that, but I am not implementing because it is not necessary. See, you can either create a reference here only, okay. You can either create here only length, int length, and at every time you are inserting, you suppose at the push operation, you can increment that length. You can do length plus plus. At the pop operation, after this you can do pop minus minus. Not after this. After this you can do length minus minus. So at this with this you can also create a function using which will return this length. Okay, the data stored in the length. So that with that, what will be the complexity of the length function? It will be big of 1, because in every insertion and deletion we are updating the length variable. Yes or no? Now second way is to create the length or the size function for this stack is to no Nitya. It will be big of 1 only. Let me explain it to you. What I am telling you, that at the time of creation, okay, let me have it. Let me have the function. So shall I add the function for size? Tell me everyone. Yes. So there are many ways. I am doing it in big of 1. So I am creating a private variable. It is of int type and it is length. Len. Okay, let it be size. See, when the object of the stack class will be created, what will happen? Two things will be created. Earlier one thing was created, that was top and it was pointing to null. Now size variable will be also created and it will be storing 0. That is the default value of integer data type. Now when we are pushing data into the stack, where it is? Yes, when we are pushing and we are pushing here, so what we can do? We can simply do length, where it is? Okay, it is size. So we can do size plus plus, yes or no? And at pop operation, after this, when we have done top is equal to top dot next, we can do size minus minus. Okay, so this is done. Now, is there any need to update the size in the peak? Yes or no? No? Cool. Now, is there any need to change in is empty? No. And neither we have to change it in the print stack. Now, quickly, let us add a function. Let us add a function that will return the size of stack. I don't know if it will work or not. I think it should work. Yes, it should work, I think. But it's showing. Now I'm making it as public. I'm making it as int because we are returning and size. Let me make it get size. And my laptop is hanging now. Now what we have to return? We have to simply return the value stored in the variable size. And let me add here. So tell me the complexity of the size function. Someone was telling it is big of n. If you don't agree, tell me the reason. If you agree, then also tell me the reason. We create a size function, then we have to iterate. Yes, that I was saying that there are two ways to do that. Okay. So one way is that we can iterate the whole stack. Okay, that is also correct. Who was telling? We can do like that also. Mihir, you are absolutely correct. We can iterate from top till the null, and we can give the size. But that will take a complexity of big O of n. Now I have done an efficient way that at the point of insertion only I am incrementing the size, and at the point of deletion I am decrementing the size. So this will not take an extra time. So yes, everyone is correct. It is big of 1. So I am adding a print ln statement. It is telling that press 6 to get size of stack. So it is sufficient. Okay, let me make this 7, and let me again add a case 6 here. Okay guys, just be with me, I will show you this. And what I have to do, I have to print the size. So s dot size. Let me keep this in a print function. So system dot out dot print ln, and let me also give a message that size of stack is equal to nothing but not s dot size. Let me keep it get size. So you can also do one thing. You can create all these functions. Okay, so this is done. See, made in this situation, what I've done now, the worst time complexity for this function get size is big O of 1. Okay, the worst time complexity is also big O of 1. Why? Because we are doing nothing in this. Okay, we are not iterating in this function. But if we change the function to that approach which you are telling, at that time the best time complexity will be big O of 1, and the worst time complexity will be big O of n. Are you getting me? Yes or no? Tell me. Okay, still if you have doubt, you can ask me on WhatsApp. Yes, I am telling in this situation, just now what I have done, this is big of 1 in best case and in worst case. But the approach which Mihir is telling, in that situation, we are iterating the whole linked list. Suppose it is having one element, then we are having in big of 1, otherwise in big of n. So at that situation, we will get two different answers. But here, we are having 1. Okay, let us check if it works or not. Let me make this one as 7. Sunil, is your doubt clear? I was talking about that approach. Cool. So now this is running. Initially, let us see what is the size. So let me press 6. You can see size of stack is 0. Now why it ended? Why it ended? So yes, after this I have missed the break statement. So after every case, you have to have a break statement. So it should prevent us from fall through. So who will tell what is fall through? It is a basic question from Core Java. Yes, I am asking that what is fall through? What happens? Let me show you. You can see when I press 5. Okay, the stack is empty. When I press 6, okay, not 6. What was the? Yes, it is 6. So I am pressing 6. The size of the stack is 0. Now let us push some elements. I am pushing again 12. I am pushing 13. I am pushing 14. And if I press 6, you can see the size of the stack is 3. Now if I pop, see if I press 2, now 14 has been popped. The size should be reduced by 2. If I press 6, the size is 2. Again I am doing pop. Again I am doing pop. Again I am doing pop. Now it is showing underflow. So the size should have been reduced to 0. So let us press 6. The size is now 0. Yes, Monu, you are correct. So all the correct as well as wrong cases are run in that situation. See what happened if I miss this break. What happened? It print the size of stack, then the code stopped. Why the code stopped? You can see after case 6 we are having case 7, which is for terminating the code. Yes or no? So it terminated the program, and then this break statement came to action. So the correct cases as well as all the wrong cases will work if you miss one particular break statement. So yes, is this approach clear? How we created the function with the name as, what is that? Yes, to get the size. Can you create the function for using iteration to get the size? Okay, there is no need to do that. Still, if you want, you can do using this. Okay, the approach is hidden in the print stack function only. So now I hope the function is clear. Yes, one more thing I have to show you, that I am checking here using ternary operator. So I am checking if the stack is empty, I am printing stack is empty. Otherwise, I am printing stack is not empty. So this is a ternary operator. If this condition is true, this is the true part that will execute. Otherwise, this is the false part. So yes, let us move to the complexity part. Any doubt in this code? Quickly tell me. We are having 4 minutes. I want to complete the complexity and the operations, real life applications. Okay. So we have seen what is a stack. We have seen the definition, understanding, and coding part. Then common operations we have seen. So we have seen creating stack. We have seen push, pop, peek. If it is empty, delete, as well as you also see the size function. Now tell me quickly. So in the terms of BIGO notation, what is the complexity for creating a stack? Time complexity. Waiting for your replies, guys. Okay, so it is big of 1. What is for push? Big of 1 only? Yes. What is for pop? Okay, so big of 1 only. So you are getting. So if anyone have any doubt, tell me, then I will explain that. Okay, if you have a doubt, tell me why it is big of 1. Ask me, sir, why, sir, this is big of 1, then I can tell you. Then peek. Again, yes. Is empty. Again, 1. Now delete is also 1. Now let me add few functions which we have created. So first is size. So for size it is one. Cool. Now suppose if we have created the size using the iteration approach, then it would have been big of n. Now what is the for printing the list? We have a print list function. Okay, print stack function. What is the time complexity for that? N. Cool. And space will be big of 1. So are these things clear? Now let us see some practical uses. Okay, you tell me guys, what are some practical uses of stack in normal technology or anything? Okay, don't give me real life example. We have seen real life example like bangles. So don't give me example for that. Give me a technical use. Bank. Priyam, can you explain? Priyam, how it is bank? Tell me. Don't worry if you are wrong. I think you are right. That's why you have been bank. Others also. Browser back and forward. Cool. Divjal, very good. Very good, Divjal. Priyam, in submitting cache line. Okay. So I think it's a queue. Yes or no, Priyam? Okay, it can be history. Sparsh, very good, very good. So you have already given 2 answers which I have added into this slide. So let me show you. So first is for implementing the back and next page in a browser. So you can see when I will go to the Chrome, the order of moving to previous and the next tabs are same. Suppose if we have opened suppose a tab as Google. Okay, let me do anything. So this Google has been pushed. Suppose then I am going to something like Google News. So this is the second node which we have pushed. Now I am going to this news, COVID using terms in India and anything. So then this is pushed. Okay, it has been opened in a new tab. So you can see when I will go back, I am going to the previous node. This is how it is getting pushed in the stack. Okay, let me show you using this also. So first the Google node was pushed. Okay, then the news page was pushed. Then suppose a particular news which I have opened like COVID, that was pushed. Now when I want to go back to the previous page, so this node is pop. So that's why I'm going to the previous page. Again, before I press the back button, I go to the previous page. So this is how the implementation of back and next page of a button in a web browser uses stack implementation. Next is solving a mathematical expression in a scientific calculator. Now you can see a scientific calculator, you can add the whole expression like a plus b multiplied by c divided by 10. This is in a bracket, again modulus 10. So this is what, this is an infix expression. Okay, this is an infix expression. The calculator converts it, I think it's converts it to a postfix expression. Okay, postfix expression before solving. Postfix expressions are what? Suppose you have a plus b, this is infix because the operator is in between. Now you will have a b plus, the operator is at last, this is postfix expression. So this is also an important question using stack, how you can convert infix expressions to postfix, postfix to prefix, and prefix to infix. So a change between all of the three. So those you can study. Okay, I will share the link on Geeks for Geeks, it is available. Second important question is that yes, that this is also important question, that from Q, okay, from Q, how can you implement a stack, and from a stack, how can you implement a queue? So let me tell you, using two queues you can implement a stack, and using two stack you can implement the queue. So that you have to study. Okay, that is your part. I have not included the questions for data structures. So these are some important questions. So in this course we have not included. Okay, those are part of the questions. You can study that later. So next is reversing a string. Suppose you have a string like hello. How can you reverse it using a stack? You can push all, you can iterate this string and you can push all the characters in the stack like H, E, L, L, O. Now you can push every time and you can print. Okay, you can create a while loop until the stack is empty. Until the stack is empty, you can system.out.print stack.pop. This is how you can print the string in the reverse format. Any more? So no, these are some few examples, and already some people have given some good examples. So any confusion in stack? So tomorrow we are going to start queue, and queue we will going to see again using linked list. We have two queue. Okay, we have a circular queue and we have a linear queue. So both of the queues we are going to see. So yes, that is it for this lecture. If you have any doubt, quickly tell me. Thank you for listening with so much patience. Let me see how many of you are there. Here we can practice infix to postfix. Sure, I will share that. Okay, just look at the screen. Is the screen visible? Yes. Just go to Geeks for Geeks. Okay, so maximum thing I have studied from Geeks for Geeks because it is free resources are available there. Go to the tutorial section, go to data structure and go to stack. So very good model questions are available for stack. So today if you can't do all the questions for linked list which I have provided yesterday, I am going to give you 20 important questions which are important for linked list. Okay, try to see those questions, how they are implemented. At least try to understand the logic, because in interviews, even if you are able to explain the logic, it is good. So I will add that link of 20 important questions in linked list, and today I'm going to add this link, that is stack. You can see these are basic questions on design and implementation. Then we have standard problems. So these are very important. Okay, so here you can see in question 2, 3, 4, infix to postfix, prefix to infix. Shall I increase the size? All right. Yes, you can see postfix to infix. Those are given here. All right. So these are some questions. Operations on stack, miscellaneous questions, reversing a queue. These you can do using a stack. So from there you can study. See, Ankita, when I was in third year, I used to do 10 questions from Geeks or Geeks for every data structure, and I finished at least 100 of questions for each data structure. Means 100 from linked list, 100 from stack, 100 from queue, like this. So you can, if you try to do 10 questions every day, means if you are not doing any other work, suppose your focus is to complete data structure and bring a good command on data structure, so you can do at least 10 questions per day. Or you can set according to your limit. If you are not, if you are a bit slow, you start doing 5 questions per day. See, Sparsh, I will give you the link from where you can study stack using array. But see, if I started giving both approaches, the course will again increase to a huge number of classes. Okay, that again will take a number of classes. That is a very complicated approach, and I will suggest you don't go with that. Just follow this linked list approach. It is easier for you. Still, if you need that, I will provide you with the resources. Just ping me on WhatsApp. Any other question? I'm waiting for you. If you have any doubt, just tell me. Otherwise, you can leave the class. I will wait 10 minutes more. Okay, it's 7:35. Because you guys say that you don't get time to ask questions, so I'm waiting. Welcome, Mono. So good night, everyone. I'm waiting for your questions. Any questions? Will interviewer ask to implement data structure using array? I don't think so. If you tell, see, interviewer ask only those things which you have written in your resume. So if you quickly tell that, sir, I have studied all the data structures using linked list implementation, so they will tell you do it using linked list only. Okay, they will not force you to do it using stack. So they always check what is your domain. Okay, what is your range in which you are sufficient. So from that range only they ask questions. So sir, please teach with the same speed as you teach today. Cool, Sunil. See, yesterday I wanted to complete the linked list, so that why I was in a bit speedy mode, and also because the things were similar from the first classes for single linked list. So that's it. So can we implement with anyone? Yes, PM, you are free. You are free to go with any implementation. But according to my experience, I was teaching linked list because it is easy and relatable. You can relate to every data structure. Can we stream live classes in PC? I think you can stream. Just log in. You have in the WhatsApp you have provided with a video. From there you can see how you can log in into PC. Okay, streaming live. Check that I don't have any student access. Otherwise, I would have checked. Check if it is at 6:30 if it is shown. Okay, if it is showing that you can join the class, then it's cool. Any more? Goodbye. So I think no more questions. Any more questions apart from the topic? No questions? So yes, thank you everyone. Let us meet tomorrow at same time, 6:30 p.m. I will be pushing the stack code in the GitHub link. Yesterday class lecture uploaded. Just check, Sparsh, check before asking. Yes, see you tomorrow. Okay, the editor which I use is Intel IJ. Okay, its full name is, let me check, Intel IJ IDEA Community Version. You can download it. It's used for backend development projects. Okay, projects using Java. I create Spring Boot projects, so for that I use those. Any more questions? Okay, so thank you.